find the inverse of the matrix, or state that the matrix is not invertible. There are some determinant methods for finding the inverse of a 3 by 3 matrix, but they're not common, and the book I don't believe covers them. However, the basic approach is you set the matrix that you're interested in finding the inverse for, you augment it with the identity matrix of the same size, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now keep looking at the right side of how this starts. This is how you want the left side to end up looking. Now, the first position is a 0. We want the first position to be a number 1. This third row has a 5, at least it has something in that position. So I'm going to swap row 1 with row 3. And the right side material goes with it. So you can take a look, our old row 1 is now our new row 3, and row 3 is new row 1. Row 2 did not change. Keeping a track of what's in green, that's what we're headed for. We now have all the zeros in position just by that swap. Next, we need to make the ones. We can do that with 1/5 on the top one, 1/5 on the second one, and 1/5 on the bottom one, distributing that all the way through. So 1/5 times 5 is 1, 1/5 times 0 is 0, and a 0, and a 0, a 0, and finally 1/5 times 1 is 1/5. Similarly, distributing the second one and the third 1/5, and we have achieved the left side looking like the identity matrix that we started with. That's the process of finding the inverse. This was C, I believe, C. The right side is the inverse. Matrix brackets, and there we have it. We could also rewrite this if we wanted to factor out the 1/5 and not have fractions inside. I would accept either of those answers. The second one might be more useful if you needed to use this inverse to, for example, solve systems. But that's it for finding this inverse. 3 by 3 inverse is a fair amount to it, so it was nice that this one was what's called a sparse matrix, mostly zeros.